Okay, so today's topic is about the spectroscopy. So generally spectroscopy. Here spectra means it is light. Okay, light. So spectroscopy is a light properties. Okay, so we need to know light about light, and scopy means it is a study. Okay, study. So actually what's happening in this means we going to study about the light when it is incidented or when it is interacted with any material. Okay, so how it is going to interact. Okay, and what could be the energy change. Okay, and what could be the change in the molecules, that we going to study. Okay, based on that study we going to define how the molecule can be observed in different energy transitions. With that specific energy transition we can identify which molecules or which changes are happening. Okay, so light interacting with the materials. Okay, light interacting with the materials, that gives the changes are going to study here. Okay, so spectroscopy means the study of light interactions. Okay, the study of light interactions with material or with matter. Okay, so it might be a solid, it might be a liquid, it might be a gas. Okay, whatever may be the material, how it is going to interact with matter or material will be studied in spectroscopy. Okay, so this is the most simplified definition about the spectroscopy. Okay, so here is the definition. So light is generally called as a electromagnetic radiation. Okay, so light is generally called as electromagnetic radiation. So electromagnetic radiation is a broad type of radiation. Okay, among that light is one type of electromagnetic radiation. Okay, so we're going to study about the electromagnetic radiation, what it could be. Okay, and matter can be a atom, can be a molecule, can be a ion, or can be a gas, can be a solid, can be a liquid. Okay, so any gas or liquid or solid if you take, that will be consist of the molecules which will be consist of the ions. Okay, so basically we'll be going to see the ions, molecules and atoms. Okay, interacting with the electromagnetic radiation. Okay, so this is what the spectroscopy studies. Okay, so spectrometer. So we need to study the spectroscopic interactions, or if we need to study the light incidenting onto the material, it's not easy to analyze with the naked eye. Okay, so for tiny particles or for micro level particles we use generally microscope. Okay, so under the microscope we're going to study about the microscopic things. Okay, similarly, to see the light interactions onto the matter, onto the atoms and onto the molecules, we need a apparatus that is called spectrometer. Okay, so the spectrometer is used for the measure of the interactions of particular compound or particular molecule or particular atom. Okay, so the apparatus which is used in the spectroscopy is called spectrometer. Okay, so we'll be going to see the types of spectroscopy and types of spectrometers also. Okay. Spectrum. Okay. So spectrum is nothing but, so if you take a mat, okay, when it is rolled, okay, so this is what light, okay, this is what light, which is the electromagnetic radiation. Okay. So if I open this mat, okay, and spread, okay, so it's going to give like this. Okay. So similarly, if you expand the light based on the wavelengths, okay, based on the wavelengths, okay, if we expand the light based on the wavelengths, so that is said to be spectrum. Spectrum is nothing but a opened mat, okay, of light. Okay, in very simple words, in the scholar words, okay, so it is the plot of light, okay, plot of light with increasing or decreasing of the wavelength. Okay. So spectrum is a plot of light with increasing or decreasing of the wavelength. Okay. So spectrum is nothing but it is a form of light which is divided or which is analyzed completely and spread into the increasing or decreasing of the wavelength. Okay. So the spectrum, how it is going to visible, what are the parts of the light also will be seen in the next slides. Okay. So simple light will consist of different wavelengths lights. Okay. So that is if it is consisting of only single wavelength light, okay, so that is said to be monochromatic light. Okay. Where chroma means color. Okay. If it is giving one color means it is having one type of wavelength. Okay. When it is called monochromatic light, it is having only one wavelength of the light. Okay. So generally light, normal light, what we are saying, normal light is going to have different kinds of wavelengths. Okay. So if you expand it, the normal light is going to give spectrum. Okay. Spectrum. Okay. So let's see details about the electromagnetic radiation. Okay. So magnetic means, so the material which is having magnetic property. Okay. So electro means it is having electric field. Okay. So radiation is a form of light or is a form of energy. Okay. So the form of energy which is having electric field as well as the magnetic field can be considered as a electromagnetic radiation. Okay. So the name itself defines the complete information. Okay. So the form of energy means every energy consists of some particles or some waves. Okay. According to Einstein. So if I take the electromagnetic radiation, okay, or this form of energy, there will be a electric field, okay, in the perpendicular direction of the progress. Okay. So if a wave is going in this direction, let's say this is x direction, so in the y direction there will be a electric field, and in the z direction means it is above and below the plane, okay, or front and back. In the z direction, okay, so I need to write like this. Okay. In the z direction it will be a magnetic field. Okay. So when it is propagating in the x direction, the perpendicular magnetic as well as the electric fields will be propagated in the electromagnetic radiation. Okay. So electromagnetic radiation అంటే ఫార్మ్ ఆఫ్ ఎనర్జీ, దానికి ఎలక్ట్రిక్ ఫీల్డ్ అండ్ మ్యాగ్నెటిక్ ఫీల్డ్ పర్పెండిక్యులర్గా ఉంటాయి. ఓకే. సో హియర్ వి సీ ద పిక్చర్ ఆల్సో. ఓకే. సో దిస్ ఇస్ ది డైరెక్షన్ ఆఫ్ ది electromagnetic radiation, EMR. Okay. So while it is propagating, so when it is moving in this direction, okay, in this direction, so there is a magnetic field exactly 90 degrees. So this is propagating axis, exactly 90 degrees there will be a magnetic field, and exactly to the another 90 degrees, and these two are also with 90 degrees. Okay, so perpendicular electric field, perpendicular magnetic field will be propagated. Okay, so that kind of energy form or radiation is called electromagnetic radiation. Okay, so this is the specialty of electromagnetic radiation. It can pass even in uh, vacant areas also. Okay, so without any matter or without any medium also it can propagate. Okay, so is it understand, or shall I repeat? Okay, so what are the parts of the electromagnetic field? It will consist the magnetic field and it will consist the electric field. Okay, so which are in perpendicular to each other to the propagating direction. Okay, propagation డైరెక్షన్ ఏదైతే ఉంటుందో దానికి పర్పెండిక్యులర్గా ఎలక్ట్రిక్ ఫీల్డ్ ఉంటుంది, పర్పెండిక్యులర్గా మ్యాగ్నెటిక్ ఫీల్డ్ ఉంటుంది. ఓకే, సో this in going to interact with the material. Okay, so that interaction we will be going to study in the spectroscopy. Okay, so these are the definition about the electromagnetic radiation. Okay, so this is the history of electromagnetic radiation, you can read out. Okay, so electromagnetic spectrum. So the earlier we have seen the radiation. If the radiation spread according to the wavelengths, okay, if the radiation is spread according to the wavelength, then it is said to be spectrum. Spectrum means it is nothing but the open mat. Okay, so generally light will have all kinds of wavelength, but when it is spread onto the uh, system, okay, when it is spread on the spectrum, okay, so you can visible all the wavelengths. Okay, so that is said to be spectrum. If it is electromagnetic radiation spread into the different kinds of wavelength, then it is said to be electromagnetic spectrum. Okay, so what are the properties about the spectrum we will be going to see now. Okay, so spectrum are wave. Okay, waves generally have wavelength and frequency and amplitude. Okay, so wavelength, frequency and amplitude. So what are these means? So wavelength. So if you start a point of the wave, okay. So let's say let me take this. Okay. So top point of the wave to the top point, next top point. Okay. So this is called peak, peak to peak. Okay. So the distance between the two peaks, okay, are two highest points, are the distance between two troughs, okay, lowest points is said to be wavelength. Okay. So if it is a longer wave or it is wavelength is more, okay, wavelength is more, this gap will be more. Okay, this gap will be more. Okay, that is called wavelength indicated by the lambda. Okay, so wavelength is the e- description unit for the electromagnetic radiation. Okay, so electromagnetic radiation యొక్క నేచర్ని చెప్పడానికి మనం వేవ్ లెంత్ని యూజ్ చేస్తాం. ఓకే, సో దీస్ ఆల్ ఆర్ లైట్ ప్రాపర్టీస్ ఆర్ ఎలక్ట్రోమాగ్నెటిక్ రేడియేషన్ ప్రాపర్టీస్, ఫ్రీక్వెన్సీ, వేవ్ లెంత్, యాంప్లిట్యూడ్. ఓకే, సో వేవ్ లెంత్ మీన్స్ ద డిస్టెన్స్ బిట్వీన్ సక్సెసివ్ ట్రఫ్స్ ఆర్ సక్సెసివ్ పీక్స్. ఓకే, నెక్స్ట్ frequency. Okay, so if I take a wave that is passing, okay, so if I keep a point, okay, keep a point, okay, and in this, from this point, okay, if I take in 1 second, okay, so I'm observing for the 1 second. So in 1 second, how many waves? Okay, wave means this part. Okay, in 1 second, how many waves can move from particular point is said to be frequency. Okay, frequency means the number of waves passed through the point or particular point at a given time or in 1 second is said to be frequency. If frequency is more in given time, more number of waves can pass. Okay, if frequency is more number of waves can pass. Okay, so if frequency is less, less number of waves can pass. Okay, and one more thing, if wave is larger, okay, if wave is larger in given time, the number of waves that can pass will be less. Okay, so if wave size is more, the number of waves that can pass in given time will be less. If wave size is less, so the number of waves that can pass in given time can be more. Okay, సో వేవ్ సైజ్ చిన్నగుందనుకోండి, ఇచ్చిన టైంలో ఎక్కువ నంబర్ ఆఫ్ వేవ్స్ దాని నుంచి పాస్ అవ్వగలుగుతాయి. ఓకే, మనం తీసుకున్న పర్టిక్యులర్ పాయింట్ నుంచి ఎక్కువ నంబర్ ఆఫ్ వేవ్స్ మూవ్ అవ్వగలుగుతాయి. సో అప్పుడు ఫ్రీక్వెన్సీ అనేది ఎక్కువ ఉంటది. ఇఫ్ వేవ్ సైజ్ ఆర్ వేవ్ లెంత్ ఈజ్ లెస్, ద ఫ్రీక్వెన్సీ విల్ బి more. Okay, if the wavelength is more, the frequency will be less. So it is indicating that the frequency is inversely proportional to the wavelength, or wavelength is inversely proportional to the frequency. Okay, so next, amplitude. Okay, amplitude. So wavelength is the distance between the two successive troughs or two successive peaks, but amplitude will be the height. Okay, height, if it is the passing axis. Okay, so if this is the electromagnetic passing axis, so the height of the wave, okay, the height of the wave is can be considered as a amplitude. Okay, so if it is more amplitude, more height will be there. Okay, more amplitude, more height will be there. Okay, so these are the terms: amplitude, wavelength, and frequency. Frequency is nothing but, yeah, inversely proportional to wavelength. Frequency is nothing but the number of waves that can observed in 1 second. Okay, so simply it is given as cycles per second, or in also hertz. Okay, so these are the units for the frequency, whereas for units for wavelength is length. Okay, length means it is meters or nanometers or centimeters. Okay, so length is what? Distance. So this is what distance units, whatever may be there, that can be applied for the wavelength. Okay, so these are the factors are you description units for the electromagnetic radiation. Okay, so next, so if you observe the electromagnetic spectrum, okay, it will be going to have different kinds of wavelength having waves, okay, or rays. Okay, so that will be going to start from the gamma rays and will be going to end with the radio waves. Okay, so generally visible light, whatever the light that we are able to see, will be around 400 to 700 nanometers region. Okay, 400 to 700 nanometers region. Okay, so let's look into the spectrum. So this is the electromagnetic radiation spectrum. Okay, so here is the visible light. Okay, here is the visible light, which is 400 to 700 nanometers. 1 nanometer equal to 10 to power of minus 9 meters. Okay, so this is about the visible light. Okay, so gamma rays will be having lowest wavelength and highest energy. Okay, there is also a relationship E equal to hc by lambda. Okay, so when wavelength increases, energy decreases. Okay, so this will be also studied in the further classes. Okay, so gamma rays are the highest energy waves. Okay, that can supply more energy when compared to all other electromagnetic radiations. Okay, so whose wavelength will be from 10 to power of minus 9 to the 10 to power of minus 11. Okay, so this is gamma rays. Okay, after that the x-rays which are with a little bit more wavelength, which are 10 to power of minus 7 to the 10 to power of minus 9 meters. Okay, so then uv rays. Okay, so which are with 10 to power of 5 to 10 to power of minus 5 to 10 to power of minus 7 meters. Okay, then it is 10 to power of minus 4 to the 10 to power of minus 5 meters. It is visible light, then IR. Okay, then microwave, then radio waves. Okay, so the highest, so if I write in the energy order, so highest energy will be gamma rays. Okay, then X rays, then UV rays, then visible rays, then IR, then microwave. Okay, so this is microwave, then radio. Okay, so if I write in terms of the wavelength, okay, so highest wavelength will be this 10 to power of 3 means kilometer. Okay, 10 to power of 3 means kilo, so it is in meters, so kilometer. Okay, so its wavelength will be in around kilometers, up to kilometer. Okay, so first radio, then microwave, then IR, then visible, then UV, then X-ray, then gamma rays. Okay, so when it is energy is increasing, their penetrating power will also increasing. What is penetrating power? The power to pass through any material. Okay, the capacity to pass through a material. Okay, so that's why X-rays are used to analyze the bone structures. Okay, so bone matters whatever are there, they will be analyzed by passing through the human body, which are used x-rays. Okay, so x-rays can penetrate through the human body, so that's why they are applied for the x-ray studies. Okay. Hmm. So they are second highest energy electromagnetic radiation. First highest energy electromagnetic radiation will be gamma rays. Okay. So these are even more powerful, which will cause the cancer. Okay. So it is very important to note this energy and wavelength relationships. Okay, so you need to keep hold of waves which are with more energy, which are with less energy, and what kind of energy or what kind of waves are present in the electromagnetic radiation, how they are going to apply in the spectroscopy. Okay, so light, each wavelength light will function or will interact with the material in different ways. Okay, so whatever the UV light that is going to interact with the atom will not be same when it is incidented IR light. Okay, so IR region లో ఇన్ఫ్రారెడ్ రీజియన్ లో ఏవైతే ఉన్నాయో అవి ఒక atom తోని ఇంటరాక్ట్ అయ్యే వే డిఫరెంట్గా ఉంటుంది ఎప్పుడైతే అల్ట్రావైలెట్ రేస్ తోని కంపేర్ చేసుకుంటే. ఓకే, సో ఈచ్ వేవ్ లెంత్ of light or of electromagnetic radiation can interact with the atoms or molecules in different, okay, in different ways. Okay, so you need to keep hold of their energy as well as the wavelength. Okay, next. Okay, so this is the pictorial view of the wavelength as well as the different lights. Okay, so here is the color light, that is what visible light. Okay, so for radio wavelength will be highest, for gamma rays wavelength will be least. Okay, so that's why the distance between two peaks or two troughs is less. Here the distance between the two troughs or two peaks are high. Okay, So one more view of gamma rays, infrared rays, ultraviolet rays. Okay, so as the wavelength increases, energy decreases. Okay, so this is with the highest wavelength, so it is least energy among all this. Okay, so this is radio waves, sorry, microwaves, even more wavelength, so it will be least energy. So here the question, among all this, which has the greatest frequency? సో ఈ నాలుగిట్లలో ఫ్రీక్వెన్సీ దేనికి ఎక్కువ ఉంటుంది? Exactly. So because their wavelength is less. In terms of energy, which is the highest? Yeah, yeah, gamma rays. Okay. So you can take the screenshot also. Okay, if it is required. So next we're going to study about the interaction of the electromagnetic radiation with matter. Okay. So it is the incident view of the light onto the matter. Okay. So when it is light is going to incident means falling. Okay, when a light is falling onto the material, okay, so there will be three phenomena. Okay, there will be three phenomena. So the first one, if I take, so this is the material. Okay, so light is falling onto this. Okay, so light can be absorbed by the material. Okay, so if it is observing among all the spectrum, okay, there are many wavelengths, no? So among that, whatever the wavelength that is observed will be missing here. Okay, the output whatever coming out after the absorption, there will be a missing wavelength. Okay, so whatever they observed, there will be a missing wavelength. Okay, and one more phenomena, there will be a emission also. Okay, after the absorption, the material, or let's say atom, it is having let's say electrons. Okay, so this is atom and this is outermost electron. Okay, so when light fall onto this, so light is nothing but a source of energy, isn't it? Source of energy. So when electron absorbs the energy, it lifts up into the next level of the energy orbital. Okay, so now it will be disappear here, it will be here. Okay, so this energy what is required to lift up the energy of the electron is absorbed from the light that is incidented. So that light will be, that wavelength will be missing in the output. Okay, so if at all this absorbed light after electron is going to deactivate, okay, or de-excite, so again it will come into the lower energy shell. So this will be again reflected out or emissioned out. Okay, so released out. So this type of phenomena is called emission. Okay, so emission. So matter can absorb the light and can emit the light, and as well as the can scatter. Scatter means if a light is passing in this direction, if I place a smaller particle in the direction of the light, it will disperse the light waves into many direction. Okay, this dispersion is said to be scattering. Okay, scattering. So what are the phenomena that's going to happen when the electromagnetic wave interacts with the material? There can be a absorption, there can be a emission, there can be a scattering. Okay, so if we are studying the interactions of the material where about the absorption, it will be absorption spectroscopy. Okay, if we study the interaction of the material in the absorption of light. Okay, when electromagnetic radiation interacts with the material, if absorption happens, or if electron excites, or if any particle of the matter absorb the energy, that spectroscopy is said to be absorption spectroscopy. If we study the light interaction with matter in the emission process, then it is emission spectroscopy. If we study light interaction in the scattering process, that is said to be scattering spectroscopy. Okay, so scattering is the natural phenomena that was observed by the C.V. Raman, Sir C.V. Raman, who got the Nobel Prize for this. Okay, so this is simply because you can see blue sky and blue water, where the light is going to scattered up with the particles of the air, okay, or particles of the cloud. Okay, so you can know more about this in the Google or in the books. Okay, so that is what scattering. Okay, so with these interactions or with these phenomena, we can identify the qualitative information and as well as the quantitative information. Qualitative means it is the type of interaction, how it is going to happen, whether molecule completely excited or part of the molecule excited. Okay, or only some bonds are going to excited, or electrons going to excited. Okay, so that qualitative or the type of study can be done with these phenomena, as well as the quantitative, how many number of the molecules that's going to excited up or emission up. Okay, so that also can be studied. Okay, quantitative, quantity, it is based on quantity. Quality, it is the type. Okay, or special. Okay, next. So generally interaction of the material can be done with different parts of the light. That is what gamma rays can be interacted, X-rays can be interacted, UV rays can be interacted, IR rays can be interacted, and visible rays can be interacted. Okay, microwaves can be interacted, as well as the radio waves can also interacted. Okay, but the thing is, when you use gamma and X-ray, they're going to not only interact with the molecule, they will deteriorate, or they will break the bonds, and they will break the atoms and the molecule. Okay, so their composition may change. Okay, or they will collapse the atoms. Okay, so when it is interaction with the X-rays and gamma rays, they will destroy the atoms and the molecule. Okay, so that's why we are less interested in the interaction of the gamma and X-rays. Okay, so we are going to consider the rest all interactions. When it is UV rays incidented an atom. Okay, when UV rays incidented an atom. Okay, so there will be electronic excitations. Okay, this energy or this wavelength, whatever the UV wavelength, is going to match with the electronic excitation. So UV radiation can give electronic changes. Okay, electronic excitation or electronic changes. Okay, and when it is the interaction of the infrared rays. Okay, infrared or IR. So does UV rays are more energetic, or IR rays? UV rays కి ఎక్కువ ఎనర్జీ ఉంటుందా, ఐఆర్ రేస్ కా? So when it is UV can excite the electron. Okay, so IR will be less energy than that, so it cannot excite the electron. Okay, because its energy is not sufficient to lift up the electron's energy level, so it will just vibrate the bonds. Okay, so if you take a carbon carbon bond, okay, it can just vibrate. Otherwise, if it is electronic excitation, there can be lift up, and our lone pair can also lift up. Okay, but that cannot happen in the IR, it can just vibrate the bond. Okay, vibrate the bond and vibrate the molecule. Okay, so UV can give the electronic changes or electronic excitation. Okay, whereas IR can give vibrational changes. Okay, vibrational changes. And next, if it is visible light also, it is almost similar to the, it is almost similar to the vibrational IR level. Okay, so this is also going to give vibrational changes. Okay, so next, microwave will not give exactly changes. Okay, this is going to mix up. Okay, so we will not consider the microwave spectroscopy. Or generally, if it is microwave, okay, so there cannot be vibrate, they cannot be electronic, they can just rotate. Okay, rotate, rotate the molecule. Okay, so least energy phenomena of the atom is rotation. Okay, which can be done by the microwave radiation. Okay, so next, higher energy phenomena will be vibration of the molecule or vibration of the atom, that can be done by the IR radiation. Okay, so little bit more energy phenomena of the change in the molecule will be electronic excitation, that can be done in UV. Okay, UV spectroscopy. Okay, so మీకు డైరెక్ట్ క్వశ్చన్స్ అడగచ్చు. ఓకే, ఆర్ కాంపిటేటివ్లో కూడా ఉంటాయి. ఓకే, సో ద క్వశ్చన్ విల్ బి లైక్ దిస్: ఇన్ యూవి స్పెక్ట్రోస్కోపీ what kind of changes or what kind of studies we will be going to study. Okay, so UV spectroscopy is about the electronic excitations. Okay, electronic excitation or electronic changes. Okay, so one more question: vibrational spectroscopy, vibrational spectroscopy can be used with the radiation. With what radiation? UV, IR, or radio, microwave. So what could be the answer? If it is vibrational spectroscopy, what kind of electromagnetic radiation we are using? It will be infrared, IR. IR will be going to give vibrational spectroscopy. Okay, so UV will be going to give electronic spectroscopy. Okay, and radio waves will be going to give, sorry, rotational spectroscopy will be given by microwaves. Okay, microwaves. So this is about the types of the spectroscopy. Okay, and types of changes in the molecules. There can be a electronic excitation, there can be vibrations, and there can be a rotation. Okay, so this is about the interactions or the types of the spectroscopy that we are going to deal in our next classes. Okay, so if any doubts, you can comment or you can post in the group. Okay, WhatsApp group. So wherever you require, you can take the screenshot or rewind this video in the YouTube. Okay, and try to write the clear notes. Okay, so these are important uh, topic for competitive as well as your semester examinations. So please keep more efforts on this topic. Okay, thank you.